Okay, composite functions. So composite functions is a very mathsy, fancy way of basically saying a function within a function. So this is all about functions within functions. And that's why sometimes the notation for them can look a little bit strange. So I've got two functions here. I've got f of x and g of x. Now, the composite function is where we put one function inside the other. So you might have, for example, f of g of x. So we say that f of g of x. And what's happened there is we actually have the g function inside the f of x. So here's my f of x. So I take my g function and I place it inside each x value of the f of x. So it's going to be placed inside both of those values. And that will form the equation of f of g of x. So I have my x squared from f of x, but it's not actually, it's 4x plus 1 squared. And then I'm going to add on 2 lots of my x, but I'm actually adding on 2 lots of 4x plus 1. So I've replaced both of these values of x from here as my equation of g, and that's fit inside of my function for f. And then I can simplify this, so I can get 4x plus 1 squared. I'm not going to multiply that out for now, and that gives me 8x plus 2. Now I can multiply out my 4x plus 1 squared, and that is times by itself. So times by itself means that I'm going to be using FOIL to multiply that out. It's a quadratic. So that's going to give me the first ones, which are 4x times 4x, or 16x squared. My outer ones, so 4x times 1. My inner ones, so again 4x times 1, and then my last ones, which are 1. And then I still have plus 8x plus 2. So that gives me 16x squared. That's all of my x squareds here. And then I've got 4x, 4x, and 8x. So that's going to give me 16x. And I've got 1 plus 2, and that gives me 3. So that would be f of g of x. Now imagine this time, I want to do it the other way around. I want to do g of f of x. Now this doesn't necessarily give you the same answer, because this time you've got f inside g of x. So it's the opposite way round. So this time, if I erase that, I'm putting my f of x inside my g of x value of x. So that's going to give me 4 lots of x squared plus 2x plus 1. Now I use brackets quite a lot, but I do find it stops you making any mistakes when you multiply things out. So that gives me 4x squared plus 8x plus 1. So that gives me my final answer for g of f of x. So you can see there that there are 2 different answers. Now imagine this time I wanted to have another function, so for example h of x, and h of x might equal 2x squared. So this time perhaps I want to do g of h of x. So h is going inside of g, and that will give me 4 lots of 2x squared, that's my h going inside, plus 1. And you can see that's taken the format of 4x plus 1, but instead of the x I have the 2x squared. So multiplying that out, I have 8x squared plus 1. Now the question might have not said g of h of x. The question might have actually said g of h of 2. So all that means is I find g of h of x, which I've done, and now I'm going to replace my x value with 2. So I replace my x value with 2. And that's going to give me, so g of h of 2 will give me 8 lots of 2 squared plus 1, which gives me 8 times 4 plus 1, which gives me 32 plus 1, which gives me 33. Now you can do it that way round. The other way of doing this is to say, let's look at h of 2, because that was the first part that I've put inside of my g function. And h of 2 is 2 times 2 squared, which is 2 times 4, which gives me 8. And then I've put that inside my g function, so I'm now finding g of 8. And g of 8 is 4 times 8 plus 1, which gives me 32 plus 1, or 33. So you can see there we get the same answer each time. It doesn't matter which way round you do it. Okay, let's have a look at a harder one then. So this time we're going to do a three-way or a triple composite function, and we're going to do f of g of h of x, which looks quite complicated, but we can do it step by step. So first of all, we're going to put h inside g. So we're going to put h inside g. So that's going to give me 4 lots of 2x squared plus 1. And this part gives me my g of h of x. And then I'm going to take this whole answer and I'm going to put that inside f. So I'm taking this whole answer and I'm now going to put that inside the f of x. And that's going to give me, so it goes into f of x. So I get x squared, which is actually going to be 4 2x squared plus 1, and that's all squared, plus 2 lots of x, which is 4 2x squared plus 1. And that would be my triple composite function, but I now need to simplify that down. So that's going to give me 8x squared plus 1, all squared, plus 2 lots of 8x squared plus 1. I probably should have simplified that first, that would have made it easier. And that gives me 8x squared plus 1, all squared, plus 16x squared plus 2, so I've multiplied out my bracket. And we could then simplify that further by multiplying out the quadratic here, which is going to give me 8x squared plus 1 times by 8x squared plus 1. It's going to be big, this one. So the quadratic using the FOIL I have first, so that gives me 8 times 8, so 64x squared. Outer, so 8x squared, so that was to the power of 4, squared times squared is 4, and then I've got my inner, so plus 8x squared, and then my last plus 1, plus 16x squared plus 2, and then finally grouping everything together, I've got x to the 4, so 64x to the 4, I have an 8 and an 8 and a 16. So that gives me 32x squared, and then I've got a 1 and a 2, which gives me plus